are 17 fish in this aquarium. How many fish are in this aquarium? That's the question we asked the kids in our studio audience. The one who made the closest estimate will compete today on Close Call! Yeah! All right. Hi, I'm Reggie Cathy, and welcome to Close Call. And now, let's meet the host of our show, the man who counted every fish in that tank, the head guppy himself, Mr. Arthur Howard.
Thank you. Welcome, everybody, to the fishiest show in town. Now let's meet our contestants. And you are?
Rob DiTargiani.
And do you have any hobbies, Robert?
Yeah, I collect baseball cards, stamps, and coins.
And approximately how many baseball cards do you have?
Over 1,500.
Ooh, okay. And you are?
Roberta Knight.
And do you have any hobbies?
Yeah, I collect seashells.
Seashells. That's very nice. And you are?
Andrew Gluckman.
And what do you do for a living, Andrew?
Well, I like tennis and bicycling.
Tennis and bicycling. Pretty good. Okay, now, before the show, we told everyone in our studio audience that one of these aquariums contains 17 fish. We asked them to estimate how many fish are in the other aquarium. Now, the actual answer is 117. Now, coming closest with her estimate of 110 is our fourth contestant, and her name is Ashanti Hosier. Ashanti, would you come down here? Take your seat. Congratulations. Congratulations. Very well done. Okay, you get your tablet there. Are you all ready to play Close Call?
Yeah.
Okay, well then let's start. Curtain, please. Well, hello there. Yes, hello. No, Tarzan, I think, went that way and turned right on 57th Street.
It's a jungle out there.
Okay. Oh, this is Big Boy, is that right?
Little boy.
Little Boy. Well, he looks great. Okay, here's our question. How many coconuts are in this wading pool? I want you to estimate the number of coconuts in this wading pool and write down your estimates. You have 10 seconds. You kids at home, you do it too. Beverly, would you come out here and help us out a minute? Oh, okay, Cynthia. You see, that's how... Okay, you see there, this wading pool is at 2.5 coconuts deep, and we want to know how many coconuts are in this wading pool. Okay, sounds like the time is up. Can I have your estimates, please?
157.
157. Well done. Okay, Roberta?
30.
30. Okay.
110.
110 coconuts in that wading pool. And Ashanti?
89.
89. Okay, what were those again? It was...
157.
157.
30.
30.
110.
110 and 89. Now, the actual number is 240, not counting the chimpanzee. And our winner is Robert. Congratulations. I'm bringing you over here because this is our playoff circle, and we're going to get back to you in a moment. But to see who Robert will be playing against, we have one more tableau. Are you ready? Okay. Reg, are you ready? Here comes Reg. Now, here's the question that everyone has been asking themselves for a long time. These are 2 small hot dogs, correct? Now, the question is, how many hot dogs tall is Reggie? Now, you see, the 2 hot dogs go from the top of his head to the tip of his nose, right? How many hot dogs tall is Reggie? You have 10 seconds to write down your estimate. And you kids at home, try it too. You look very good that way, Reggie. Okay, let's see what the estimates are first. Roberta.
32.
32.
31.
31, very close.
And 70.
And 70. She estimates you very highly. Okay. Now, to find out, do we have anything back there to help us measure? Well, why don't you bring it out? This is something that I'm sure every household has. It's the sausage measurer, okay? And the answer seems to be 27. So coming closest is Andrew. Congratulations. I'm going to wheel you over. I think I'm going to wheel you over. There you go. Now you two are our finalists, Robert and Andrew. The winner of this round is going to be today's champ. Are you ready? Now this next question is a little complicated. Cynthia and Beverly, are you ready?
Yes, we are.
Well, then come on out. Okay, good. They're going to set up the cones. This is a conehead question. Oops, sorry. You all right? Okay, and also, could we have our two commuters, please? Just two of them from back there. Good, okay. What's your name? Amma. Would you stand right next to this A? Okay, but right next to it. Good, and what's your name? You're Arthur too? But I'm Arthur. Okay. You're Arthur 2 and I'm Arthur 1. Okay, put the newspapers right next to each other and go on a diagonal heading for that cone. Okay, as I said, it's a little complicated. Now these are two members of our studio audience holding newspapers edge to edge, right? Now the question is, how many kids with newspapers will it take to continue the path from cone A to cone B to cone C to cone D and back to cone A? Okay, how many kids with newspapers will it take to go from here to here, back to cone D, and all the way back to cone A? Estimates, please. What are you reading there? Okay, time is up. Can I have your estimates?
25.
25. And Robert, you say?
20.
20. Okay, it's 25 to 20. I'm just curious, how many kids over here think Andrew's closest? Clap if you think so. No one does. How many people think Robert's closest? Okay, well, we're going to find out. All right, may I have the curtain, please? All right, people, would you come around and help us out? You stand right here. Put the papers edge to edge. Okay, come on. Let's see. Boy, these are well-behaved. Okay, wherever you should be. Good, good, good. Okay, this is a very well-read group here. Okay. Remember, keep the papers edge to edge. I'd like to see the edges touching, okay?
You got it.
Good, good. You do this every day, right? No? You don't? Okay. Here. Okay, wherever you should be, there. I guess you should be touching edge to edge. Okay, now, let's find out how many there are. Can we have a count-off? Ready, and...
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22.
The answer is 22, and our winner is who? Is Robert. Congratulations. Okay. Well, that's all we have time for today. Robert, congratulations. For the runners-up, we have Square One TV sweatshirts. For everyone else, for the winner, that is, we have a Square One TV sweater, and that's all we have time for today. So see you next time on Close Call. Bye-bye.
Hello? Hello? Anybody home? No. Oh, man. Lucky I found this old haunted castle. Wow. Oh. Wow. Hey, look at this. It's one of those magic lamps. You know, the kind people rub on Saturday morning cartoons? Then something dumb happens, like a commercial. How about that? It is a magic lamp.
Thank you for letting me out of the lamp. My foot was falling asleep.
Are you a genie?
Yes, I am a genie, and my name is Fleet, for I'm swift of mind.
How do you do, Fleet, the Genie? I'm Howard, for I'm an accountant. Are you going to grant me 3 wishes?
No, I only grant 1 wish, but I validate parking. What might your wish be?
Fleet, I would like to know the amazing story of nines.
1 wish, and that's all you want to know is the amazing story of nines?
Uh-huh. Can you do it?
Oh, sure, but you could have anything. Gold, health, eternal youth, tickets to Springsteen concerts.
Just the amazing story of nines, if you please.
Very well, Howard, the accountant.
Yes, Fleet, the Genie.
Get comfortable and listen. There are some attributes to our simple number 9 which, through the many years of our present system, have not gone unnoticed by wise Genie.
Oh, I like it already.
One amazing quality is apparent when we multiply any number times the number 9. Tell me, what is 9 times the number 1?
Hey, how'd you do that?
There are some things mortal man is not meant to know.
9 times 1 is 9.
How much is 9 times 2?
9 times 2 is 18. But what is so amazing about that?
18. That's right. And here is something amazing. Add the 2 digits together, the 1 and then 8.
The 2 digits of the number 18, 1 and 8 are 9.
Now, multiply 9 times 3.
9 times 3 is 27.
Add the 2 digits.
2 and 7 equals 9. Tell me, what would happen if I were to multiply 9 times 4? Will it work?
Try it.
Okay. 9 times 4 is 36. 3 plus 6 equals 9. Fleet, this is amazing.
Yes, isn't it?
9 times any number, huh?
Go for it, Howard.
Okay. 9 times 5 is 45. 4 plus 5 equals 9. 9 times 6 is 54. 5 plus 4 equals 9. Amazing! 9 times 7 is 63. 6 plus 3 is 9. 9 times 8, 72. 7 plus 2 equals 9.
Can you believe that? I forgot my keys. I'm locked out of my lamp.
Multiples of 9.
How about this, Fleet? What if I multiply 9 times 2,375? Will that work?
Yes, Howard. Try it.
Gee, I wish I had my calculator.
You've already used up your wish, but you can borrow mine.
Gee, thanks! 9 times 2,375. Okay, the answer is 21,375. Now, how does that work?
Well, add the digits of the product. You know, 2 plus 1 is 3.
Uh-huh.
Plus 3 is 6.
Yeah.
Okay. Plus some 7 is 13. Plus 5 is 18.
I see. And then I add those 2 digits, I get 9 again. Fleet, this is amazing.
I didn't have to be a genie. I could have been a junk mail recipient.
The phone again? A mathematician can't get any peace. I think I'll just kid whoever is calling. Hello, this is Nurk Diblock, a famous plaster of the lath brigade. Oh, Mommy dearest, you knew it was I right away. Well, yes, I guess I do have to get up pretty early in the morning to put one over on you and Fred C. Dobbs. What's that? You found yet another mathematical shortcut? Lay it on me. I mean, tell me, please, what is it you've discovered, Mater? If I take a number Any number, add up the digits. Yes. And those digits add up to a number that is divisible by 9. Then the number you started with is divisible by 9. Yes, that's right. Divisible means with no remainder, nothing left over. The quotient is a whole number. Oh, you got my drift, did you, Mommy dearest, you little fox? You certainly will. The mother of me just wanted me to remind you that a number is divisible by 9 if the sum of its digits is divisible by 9. Take, for example, the number 477. 4 plus 7 plus 7 is 18. 18 is divisible by 9. Therefore, 477 is divisible by 9. I think I'll try it with 6,543. Boy, howdy, mothers are smart creatures.
It worked again, Fleet. Give me another number.
Don't you think you've had enough?
Well, it was my wish.
Okay. But why don't you just believe that whenever you multiply...
9? I do believe. Oh, it's just so much fun checking it out. Oh, give me another number. Give me.
9 times 380,252.
Okay. The answer to that is 3,422,268. Now, 3 plus 4 is 7. Add 3 2s, that's 13. Add 6, 19. 8 more gives 27. 2 plus 7 are 9. Oh, Fleet, you've made me a happy accountant.
I'm glad. and let me ask you this. What would you wish for if I gave you one more wish?
Oh, well, if I had one more wish, Fleet, I'd wish that I could be back at my accounting firm, Nishak, Bushwhack, and Abindigo, so that I could show everyone the amazing story of the 9s.
I'm not supposed to do this, but maybe just this once, I can give you an extra wish.
Can you do it, Fleet? Can you really do it?
I don't know. You have to wish and concentrate very hard.
But what if you can't do it? What if it doesn't work?
To quiet you, I would tape your tongue and box your ears.
Oh, Fleet, don't flail me now.
I thought he would never leave.
Thank y'all, thank you. Well, I'd like to welcome you here to Tillis tonight, and we hope you're having a real good time. For our next little thing we're going to do for you, it's a little number that was a real big hit for us. It's called 9, and well, we hope you like it. 5, 6, 7, 8. 999, fantastic number 9. It's perfectly consistent. It works out every time. 999, that crazy number 9. Times any number you can find, it all comes back to 9. 2 times 9 is 18. 8 and 1 is 9. 3 times 9 is 27. 7 and 2 is 9. 4 times 9 is 36. 6 and 3 is 9. 5 times 9 is 45. 5 and 4 is 9. 6 times 9 is 54. 5 and 4 is 9. 7 times 9 is 63. 6 and 3 is 9. 8 times 9 is 72. 7 and 2 is 9. 9 times 9 is 81. 8 and 1 is 9. 999, fantastic number 9. It's perfectly consistent. It works out every time. 999, that crazy number 9. Times any number you can find, it all comes back to 9. 9 times 10 is 90, just drop the 0 sign. 9 times 11 is 99, makes me rhyme with another line. Then 9 and 9 is 18, and 8 and 1 is 9. Times any number you can find, it all comes back to 9.
Does this work with bigger numbers too?
Yep.
Let's try this. 3,480. 3,487.
9 times 3,487 is 31,383. 3 plus 1 plus 3 plus 8 plus 3 is 18. 1 plus 8 is 9. It always works. 999, fantastic number 9. It's perfectly consistent and it works out every time. 999, that crazy number 9. Times any number you can find. It all comes back to 9. It all comes back to 9. It all comes back to 9. Yes, sir. Ah, sir.
The story you are about to see is a fib, but it's short. The names are made up, but the problems are real.
It was Tuesday, 9:43 a.m., and the high winds which had been playing havoc with the surfboard and debating tournament finally died down. I was working the day watch out of Mathnet. The boss is Thad Green. My partner is George Frankley. Head of our computer division is Debbie Williams. My name is Monday. I'm a mathematician. A series of robberies have been taking place in the San Fernando Valley. We were asked to help out LAPD's crack robbery division. Chains of tire stores, hair salons, fast food outlets, and gas stations have been decimated in the last month. We had to stop this insidious criminal activity. We decided to take a look at a couple of scenes, courtesy yesterday's show, to get us thinking again.
There's been an unusual series of holdups in the valley, and there seems to be a pattern to some of them.
We decided to talk with a recent victim, the manager of a fill-up, pay-up, and get-out gas station.
I turned around, next thing I knew he had a gun on me, told me to open the till and give him all the money.
And
I did. He got all of it, $3,000.
Anything else?
Not really. Well, there was one thing.
Yes, sir?
Yes, sir.
That's why I wondered if I should have called the SPCA. You know, the animal shelter people?
Sir?
He talked like a duck.
Morning, Kate.
Hi, Kate.
Morning, Mathnetters. Just going over the facts?
Actually, George was just asking me about my weekend.
Oh, was he?
We were just chewing the fat, Kate.
Don't let me interrupt.
Actually, we were looking into those robberies, Kate. They're massive.
In what sense?
I totaled the monies that have been stolen so far. They add up to more than $100,000.
How many robberies have there been?
21, Kate.
Let's see, $100,000? That's an average of about $5,000 per robbery.
And it looks like there is some sort of pattern.
Mostly, he seems to rob one type of store and then stop and move on to another type of store.
If it is one man, we don't know that.
True. One person could have robbed the tire stores, and somebody else robbed the fast food places, and somebody else could have knocked over the hair salons.
Debbie, can you go through these robbery reports and build up a database on your computer?
Sure, but what kinds of questions do you want answered? A computer is only as good as the people who use it, Mathnetters.
Well, how about... who were the robbers?
Be specific.
Okay. Was there always one robber?
Was it a male or female?
Right. Was he or she always dressed the same?
Did he wear a mask?
Did he always flash a gat?
You mean did he show the victims a gun?
Yes.
Did he or she always walk away from a robbery?
Is that enough to start with, Debbie?
We should also find out when, where, and how the robberies were committed. I'll see what we can put together.
George, I've been thinking. If this is one person who's committing these crimes, we can expect him to rob another gas station. He's hit 3 already.
I was thinking the same thing, Kate. I checked, and there are 2 more fill-up, pay-up, and get-out stations in the valley that weren't robbed. Maybe we ought to stake them out.
Good idea. Wait. Where are they?
One is in Pasadena, Colorado, and Fair Oaks, and the other's in Chatsworth on Devonshire.
We'll take Pasadena and get Sam and Steve to stake out Chatsworth.
Oh, can we switch those assignments?
Sure. Why?
Well, if we go to Chatsworth, I can pick up my shirts.
Sam and Steve staked out the Pasadena station and waited. When you're trying to solve a problem, any problem, patience is often a virtue. George and I went to Chatsworth to wait. We stopped for George's shirts, but they weren't ready.
Sure is a lot of sitting in this job, Kate.
Say that again. We've been here 3 hours.
There's always the possibility that this station won't get robbed.
Right.
Well, I sure hope our station gets robbed before Sam and Steve's. Martha and I want to go to the Flickers tonight.
What are you going to see?
A movie. Kate, look.
Come on, partner. This is it.
You want what? You heard me. Give it to me. You've got to be kidding.
Freeze. Mathematicians.
Take it easy and nobody's going to get hurt. Get your hands on that gas pump.
What's the big idea?
Do as he says. George, frisk him.
He's clean, Kate.
What are you people doing?
Trying to keep you from being robbed.
Robbed? He wasn't going to rob me, were you? Oh, of course not. I just asked him if I could borrow a jack handle. I got a flat tire about a block from here, and I lost my jack handle.
Oh.
Oh.
Sorry.
Sorry.
That's okay.
Sorry, sir. We made a mistake.
I understand.
11 Adam 12, Mathnet, come in.
Excuse us?
Must be Sam and Steve.
Excuse me.
11 Adam 12, Mathnet, come in.
Monday, come in. Sam, Steve.
Kate, it's Sam.
Did they hit your station?
Not exactly. How about yours?
Nothing. Why are you calling?
I just got a report on something that may interest you.
What is it?
A 10-4 convenience store just got robbed.
That happens a lot, Sam. So what?
The guy sounded like a duck.
Yeah, well, you can take your jack handle and...
100% of Square One TV is a production of the Children's Television Workshop. This program was made possible by grants from the National Science Foundation, the Corporation for Public Broadcasting, the Andrew W. Mellon Foundation, the U.S. Department of Education, and the Carnegie Corporation of New York.
This is PBS.
Local broadcast of this program is made possible by an underwriting grant from the Grumman Corporation. Grumman Corporation, a Long Island company committed to education.